Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. So in this video, we're going to move to next topic. Okay, topic 2, which is capacitor and dielectrics. In this topic, we have 3 subtopic, 2.1, 2.2 and 2.3. But for this video, we are focused to 2.1 only, capacitance and capacitors in series and parallel. Capacitance and capacitors in series and parallel. So in this subtopic, you need to define and use capacitance, where the formula is C equals to Q over V. And then B, derive and determine the effective capacitance of capacitors in series and parallel. C, derive and use energy stored in a capacitor, where energy stored, the symbol is U. U is equals to half CV squared. U also equals to half QV and equals to half Q squared over C. Okay, we know that capacitor had been used widely in our daily life, such as phone, laptop, TV, and many more. So do you know what is capacitor? So a capacitor, sometimes called a condenser, is a device that is capable of storing electric charges or electric potential energy. It consists of 2 conducting plates separated by a small air gap or a thin insulator. We call it as dielectric, such as mica, ceramics, paper, or even oil. This is the symbol for a capacitor. The conductors could be rigid metal plates facing each other, or a pair of insulated metal foil rolled into a cylindrical casing. Capacitance. The symbol is C. It is the ratio of the charge on either plate to the potential difference between them, where the formula is C equals to Q over V. Q is the charge of one of the plates and V is the potential difference across the 2 plates. It is scalar, and the unit for capacitance is farad or coulombs per volt. So 1 farad is equivalent to the charge of 1 coulomb stored on each of the conducting plates as a result of a potential difference of 1 volt between the 2 plates. So 1F equals to 1C over 1V. 1 farad equals to 1 coulomb over 1 volt. It is always a positive quantity. So the ability of a capacitor to store charge is measured by its capacitance. The larger the capacitance, the more the capacitor can store the charge. Capacitance measures the charge on the capacitor for a unit voltage across it. By rearranging the equation from the definition of capacitor C equals to QV, we rearrange, we get Q equals to CV, where the capacitance of a capacitor C is constant. So, Q is directly proportional to V. That means the charge stored Q is directly proportional to the potential difference V across the conducting plates. The greater capacitance of a capacitor, the more charge is required. Okay guys, so before we proceed to example 1, so I hope you know the difference between capacitance and capacitor. Right, okay, look at example 1. The capacitance of a capacitor is 20 microfarad. What is the charge on each plate to a potential difference of 6 volt and B 9 volt? So we need to find Q. Okay, we list out the information first. C equals to Q over V. We need to find charge. So Q is equals to CV. So for A, V is 6 volt. So Q equals to 20 microfarad. Okay, micro is to the power of negative 6. And our V is 6. So 20 times to 6 equivalent to 120 micro. The unit for C charge is coulomb. Okay, how about V? How about B? Question B. Q equals to, the capacitance is still the same, 20 micro times to 9. So 2 times 9, 180 micro coulomb. Okay, the capacitors can be connected in series and parallel in a circuit. So this one showing that C1, okay, C2 and C3 is connected in series. This is because, okay, the current flow or the charge flow from the voltage, okay, passing through the C1, C2 and C3 in only one route. So we call this combination as series. So the second one, the capacitor is called to be connected in parallel. This is because the charge from the voltage here, okay, passing through, and then you can see the junction. That means the charge can be separated into route 1 passing through C1, or route 2 passing through C2, or route 3 passing through C3. So since we have junction and 3 routes, we call this combination as a parallel combination of capacitors. In this topic, you're going to see frequently C symbol of C referring to the capacitance, symbol of Q referring to the charge for one plate of the capacitor, and also V referring to the voltage of the capacitance. Okay, so now we will look at the combination of capacitors in series. So we have 3 capacitors and 1 voltage. Okay, voltage here, and then C1, C2 and C3. So we can simplify this circuit. Okay, we can simplify this circuit to more simple circuit. Okay, we can simplify C1, C2, C3 into C equivalent, where at this C equivalent it owns V total and Q total. So in series combination, Q total is equals to Q1 equals to Q2 equals to Q3. Okay, you need to remember that for series combination, the charge for each capacitor is the same. So how about V? Okay, so V total here is equivalent to V, but this V is equals to V1 plus V2 plus V3. Okay, so this capacitor have its own potential difference as V1, C2 with V2, C3 with V3. Okay, so how to find the equivalent capacitance? Here, how to find this equivalent capacitance? Okay, so V1 plus V2 plus V3 is equals to V total, where this V1 is equals to, okay, from C equals to QV, V1 is equals to Q over C1, V2 equals to Q over C2, and then V3 equals to Q3 or Q over C3. Okay, if we know the value of charge and the value of the capacitor, we can determine the value of the potential difference across the capacitor. Okay, but the question is how to find the C equivalent. Okay, we know that C equivalent will be equals to Q total over V total. Okay, where V total is equals to QT over CEQ. So this VT equals to QT over CEQ, or equals to V1 plus V2 plus V3. Okay, by using this one, we can determine the value of C equilibrium, where Q total, we let it as, so I continue here, Q total is Q over C equilibrium equals to V1 is equals to Q over C1 plus 2Q over C2 plus 2Q over C3. Since the charge is the same, we can cancel all this charge. We will get 1 over CEQ is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So, the most important that you need to understand or you need to know is C equilibrium. For series combination, we are using this one. 1 over CEQ equals to 1 over C1 plus 1 over C2 plus 1 over C3. And the charge for series combination capacitor is the same. How about the potential difference across the capacitor? So V total equals to V1 plus V2 plus V3. And this V3 is equals to Q over C3. Okay, clear? Okay guys, so now we look at capacitors connected in parallel. Okay, so for this parallel combination, the charge for C1 is not equal to charge for C2 and C3. Okay, why? Let's say from the voltage, the charge supply is 50 coulomb. So 50 coulomb coming from this V passing through here and then till this junction. So that 50 coulomb needs to be distributed. Okay, according to C1, C2 and C3. So it depends. Okay, so either 20 coulomb will be going to C1, 10 coulomb going to C2, and then another 20 coulomb going to C3. Okay, they will passing through the charge. The charge will passing through the capacitor and then moving to the end. So it will see this junction. So at the end of this junction, the total charge will be equals to 50 coulomb. So that 50 coulomb charge going back to here and passing through and going back to V. So the key for parallel combination is the charge for C1, C2, C3 is not the same, but the potential difference across C1, C2 and C3 is the same. Okay, the voltage across the capacitor are the same. So how about C equivalent? Okay, so we simplify the circuit first. Okay, so simplify the circuit to only one capacitors only. So this one is C equivalent V. Okay, for parallel combination, Q1 plus 2Q2 plus 2Q3 is equals to Q total. So the Q total at C equilibrium. Okay, so Q1 here, it is equals to C1 V, Q2 C2 V, and Q3 C3 V. Okay, so to find the C equilibrium from the equation, C equilibrium equals to Q total over V. Okay, so since Q total is apa yang sama kat sini so to find the C equilibrium, it is equals to QT over V. So when we take Q total as a Q total as a subject, it will be equals to C EQ times to V. Okay, so we write CEQ V at the left side, and we know that Q total is equals to Q1 plus Q2 plus Q3. So we can substitute Q1 with C1V plus 2 C2V plus 2 C3V. Since V is the same for V total with V1 and V2, we can cancel it and we get C equivalent equals to C1 plus C2 plus C3. Okay, so for parallel combination, V total equals to V1 equals to V total equals to V1 plus V2 plus V3. Astaghfirullahaladzim, sorry. So for parallel combination, V total is equals to V1 equals to V2 equals to V3, and the charge is not the same. Q total equals to Q1 plus Q2 plus Q3, and C equivalent equals to C1 plus C2 plus C3. Okay, that is the theory for capacitors connected in series and parallel. So next we will look at the example. Okay, we will doing example 2 and example 3. Example 2, find the total capacitance. Okay, for question A, B and C. So you can see A is connected in parallel, B series, and C we have parallel and series combination. So for C question, that means this is a combination of series and parallel capacitor. Okay, so how to find the C equivalent? So C1, C2, C3 connected in parallel. So we just use C equilibrium equals to C1 plus C2 plus C3. C1 is equals to 5 micro plus 2 10 micro plus 2 15 micro 20 30. So it is equivalent to 30 microfarad. The unit is farad pula. So in parallel, the total capacitance is given by plus. Okay, we just add 1, 2, 3, and then we get 30 microcoulomb. Okay. So how about B? B is connected in. Okay, belum lagi B. Series. So for series, 1 over C equilibrium is equals to 1 over C1 plus 1 over C2 plus 1 over C3. So the value of C1 is 1 over 5 plus 2 1 over 10 plus 2 1 over 15. Don't forget to write the micro here. Okay, so ini kena guna calculator lah. So 5 5 inverse plus to 10 inverse plus to 15 inverse, and then inverse back the answer, we get 2.727. So we can round off to 2.73. Okay, the C equilibrium is equals to 2.73 microfarad. Okay. Next. Okay, next, we need to simplify the circuit first. Okay, so look at the diagram. We can see that C1, C2 and C3 is not in series or is not in parallel combination, but it is in combination, okay, of series and parallel. So what you need to do is you need to simplify first. So which one is more complicated? So you can see C1 and C2 is parallel, so you can combine it. So now it becomes C1, 2. And then we have another one C, which is C3. Okay, so this C12 is equivalent to what? C12, we have junction with 2 roots. So this is a parallel combination of 1 and 2. So this C12 is equivalent to C1 plus C2. 1 is 5 microfarad, 2 is 10 microfarad. So substitute the value, 5 micro plus 2, 10 micro. So equivalent to 15 microfarad. So you can write here 15 microfarad, and C3 also 15 microfarad. So how to find C equivalent? So to find C equivalent, C12 and C3 are connected in series. So C equivalent here, okay, so it is connected in series. So 1 over CEQ equals to 1 over C12 plus to 1 over C3. So equals to 1 over 15 micro plus to 1 over 15 micro. So we get .5. So this C equilibrium, mana nak tulis ni? Di bawah ni, muat tak? C equilibrium equals to 7 microfarad. Okay, since tak muat, awak tulislah dekat mana-mana. C equilibrium equals to 7.5 microfarad. Okay, let's continue with example 3. Find the potential difference across charges. Find the potential difference and charges across capacitors X, Y and Z. So we need to find V, X, Vy, Vz, and also Qx, Qy and Qz. So this is the diagram. We have XYZ capacitor with 12 volt. So first thing is you need to simplify. Okay, so let's simplify. So Cx, Cy, Cz, Cy and Cz are connected in parallel. Okay, so Cx So Cx is 6 microfarad, and since we already combined this Y and Z, we can write it as CYZ. Okay, so C is equals to where it is equals to 1 micro plus 2 micro. Okay, so okay, we have this diagram. It is not simplified yet, but as you can see from this diagram, Cx, Cy, Z are connected in series. So what can you say about this circuit? So we give name as A. So at A circuit, what can we write is Qx is equals to Qyz. Okay, equals to Q total. Is it right? Okay, and then at this combination, this one is a parallel combination, means that Vy is equals to Vz. Okay, but the charge for Qy is not equals to Qz. And then other than Q, how about V? So Vx plus Vyz will be equals to V. Okay, so next is we find the C total first. Okay, so to find C total, we have C equilibrium with voltage. Okay, this is C equilibrium. This is voltage. Okay, the voltage is equivalent to 12 volt. So how to find C equilibrium? Okay, here Cx, Cyz are connected in series. So 1 over C equilibrium equals to 1 over Cx plus 2 1 over Cyz, where it is equals to 1 over 6 micro plus 2 1 over 3 micro. So 6 inverse plus 2 3 inverse. C equivalent is equals to 2 microfarad. So guys, so this is the simplified circuit. So you can write all the information at the capacitor. So this one is 12 micro. Sorry, it is not 12. Equivalent to 2 microfarad. And V total is 12 volt. How about Q total? So we can find Q total by using the equation C equals to Q over V. So Q total is equals to Q equals to CV. Okay, C equilibrium times 2 V total. So C 2 micro times 2 12 So 2 times 12, 24. 24 microcoulomb. So at the C total, C equilibrium, it is 12 microcoulomb. Okay, we need to find the voltage. Kita nak kena cari the potential difference across X, Y and Z. Kita ambil balik gambar yang simplify tadi. Kita copy and paste here. Oops. So saya ambil sikit sajalah. Yang ni je lah kan. CX, CY and CZ. And kita ada yang ni tadi. Kita dah cari dia punya equivalent. Okay, this is the equivalent. So we already found out that QX equals to QYZ equals to Q total. Okay. So QX is equals to QYZ equals to Q total, where it is equivalent to 24 kan? Balik. It is, this one is 24, okay? 24 microcoulomb. So it is 24 microcoulomb. So we have QX equals to 24 microcoulomb. So how about VX? So Vx is equals to V. How to find V? C equals to Q over V. So V equals to Q over C. QX over CX. Okay, just simple like that. If we need to find X, so all we use X. So QX is 24 microcoulomb divided by CX. CX is 6 microfarad. So 24 divided by 6 equivalent to 4 volt. Okay. So X, kita dah cari semua. Kita dah cari potential difference, Vx and Qx. So now we will look at Y. So Y, this is about the total. Kita tak nak yang ni, kita nak yang ada Y and Z. This one So copy and we will paste here. So this information, we don't want this. Okay, QX and VX done. Okay. So from this diagram, since we have Vx, equals to 6 volt, and we know that the V total here is equals to 12 volt, so we can find Vy and Vz. So V total equals to Vx plus Vyz, where Vyz is equals to 12 minus 2, 6. So it is equals to 6 volt. Okay, so 6 volt. Kita lukis balik gambar Y and Z tadi. Okay, this is CY atas, CY and CZ. So so since Y and Z is in parallel, that's mean VYZ is equals to VY equals to VZ, where it is equals to 6 volt. Oh ni Vx tadi bukanlah equals to 6, it is equals to 4. So VYZ is equals to 8 volt. Okay, so it is equals to 8 volt. So VY 8 volt, VZ 8 volt. The question is we need to find Q and V. So we can find QY. Okay, QY is equals to Q equals to C times V lah. From the equation C equals to QV, Q equals to CV. So CY times to VY. So since we have information about CY and VY, we just substitute it. CY equals to 1 microfarad. Yes, C1 is 1 micro. 1 micro times to 8. So QY is 8 micro coulomb. So Q for Z is equals to Q equals to CV, CZ, VZ. 2 micro times to V is 8. So it is 16 micro coulomb. So do we answer all the question? Q total, and then we have Vx and Qx. Qx is 24 microcoulomb, Vx is 4 volt. Okay, so we check first. Qx ada, Vx also ada, Qy ada, Vy ada, Vz ada, and lastly is QZ. So we have all the information about the X, Y and Z. Okay, that's all for X. Okay class, so look at the last one. Energy stored in a charged capacitor. So when the switch is closed, charges begin to accumulate on the plates. A small amount of work is done in bringing a small amount of charge delta Q from the battery to the capacitor. So we know that C is equals to Q over V. So work done, okay, small amount of work delta W is equals to V delta Q. So by rearrange the equation, substitute V with Q over C. Okay, dia dah lari tadi. So kita tengok yang ni. So delta W is equals to delta Q times V. So So we substitute this V with Q over C, Q over C times to delta Q. So we can find the total work done required to increase the accumulated charge from 0 to Q is given by, so how to find the work done? So W is equals to from 0 to Q, from 0 to Q. Okay, it is V dq ataupun V delta Q, V dq. So when we integrate, we substitute V with Q over C, Q0, this is Q over C dq. So it will be equals to, we take out 1 over C. Integrate Q, we get Q squared over 2. Q squared over 2. Q squared over 2. Okay, from 0 to Q. By substitute this Q with Q charge, it will be equals to 1 over 2 Q squared over C. So the work done in charging the capacitors, okay, is equivalent to half Q squared over C. The work done in charging the capacitor appears as electric potential energy U stored in the capacitor, okay, equals to Q squared over C. Since Q is equals to CV, so we can substitute, okay, or rearrange the equation. So we will get these three equations: U equals to half Q squared over C, or U equals to half CV squared, or U equals to half QV. So it depends on the situation. Okay, if we have information about Q and V, so we can use this one, U equals to half QV. If we have information about Q and C, then we can use U equals to half Q squared over C.